Hi, Dr. P here, and in this lecture we'll start in on chapter 30 and we'll look at pericyclic reactions. So I want to go over what pericyclic reactions are in general and look at a few different types of pericyclic reactions. So pericyclic reactions feature a concerted mechanism that is, there's a single step. So this is like the Diels-Alder reaction, or rather the Diels-Alder reaction is an example of a pericyclic reaction. The electrons are going to move in a, basically move in a circle. Let's just put it that way in our mechanism. We've got several types. We have cycloadditions. If I could write C-Y-C-L-O, there we go, additions. And these are things like the Diels-Alder reaction. And if I was going to draw my little mechanism here, I'd add in where my new bonds are forming and my arrows to show my electrons moving. And again, they're moving around in a circle there. And this happens all in one step. And we get our product. Now, interesting, we can count our number of bonds before. Remember, a double bond is a sigma bond and a pi bond. So I've got 1, 2, 3, 4 sigma bonds and 1, 2, 3 pi bonds. And then looking at our product and what types of bonds we have after the reaction, we've got 1, 2, 3, 4, 5, 6 sigma bonds, 6 sigma, and 1 pi bond. So our change in bonds is we're gaining 2 sigma bonds and we're losing 2 pi bonds. Another type of pericyclic reaction is, are electrocyclic reactions. An example of this might be something like this, where we have H nu, that's our UV light that we will irradiate with. We're going to form one new bond there, and our electrons are going to go like that, again, around in a circle. Now we end up with a 4-membered ring as our product, with a double bond there. And in this case, we happen to get our 2 methyl groups are sticking up. And again, if we look before, we have 1, 2, 3 sigma, 2 pi, and then after, we've got 1, 2, 3, 4 sigma, and 1 pi bond for a change of +1 sigma and -1 pi bond. Okay, so in a cycloaddition, 2 pi bonds are being converted into 2 sigma bonds. And in an electrocyclic reaction, we have a net conversion of 1 pi bond into 1 sigma bond. A third type of pericyclic reaction are sigmatropic rearrangements. And so an example of a sigmatropic rearrangement is, let's see here, the following. And what happens is we get a change in the bonds. So we get a new single bond over there, new single bond there. That's now a double bond. We still have that there, and that guy's a double bond there. So looking before, we have 1, 2, 3, 4, 5 sigma and 2 pi bonds. After, we have 1, 2, 3, 4, 5 sigma bonds and 2 pi bonds. For no net change of pi and sigma bonds. Now, of these reactions, I'm really not going to talk much about the sigmatropic rearrangements. The text does go into some detail with sigmatropic rearrangements, but I'm not going to hold you responsible for that. I'm just going to show you some examples, just basically to introduce you to them. All right. Let's see. There are some interesting details to some of these pericyclic reactions. And perhaps the most interesting, the most important, are the reaction conditions, whether we have thermal reactions, where we heat them up, or photochemical, where we irradiate with light. So just as an example, we would see that, I'm going to go ahead and draw in my arrows here, my mechanism arrows. We get a reaction with the Diels-Alder reaction when it's heated up. But if we try to do a Diels-Alder reaction in the presence of light, UV light, that's my H nu there, we get no reaction. So we would say the Diels-Alder reaction is thermally allowed. So we'll say thermally allowed. And photochemically forbidden. Now, we could have other types of cycloaddition reactions. Here's an example. Where we could take an alkene and then another alkene and react them together. Well, turns out they won't react under our thermal reaction conditions, so we call this thermally forbidden. But this reaction, it turns out, is photochemically allowed. Okay. Now, electrocyclic reactions, actually, we see something slightly different. And like I showed before, and I should go ahead and put put in my... we get this product when we do the electrocyclic reaction of our that particular diene there. But when we do the reaction, that's not supposed to be H nu. I'm sorry, guys. Delta. When we do the reaction with heat instead of light, we end up getting a different product. So we could have a photochemical product, or a thermal product. Okay, now how do we figure this out? How do we figure out which cycloadditions are thermally allowed and photochemically forbidden, or thermally forbidden and photochemically allowed? How do we figure out which electrocyclic reactions give photochemical, or how do we figure out what the photochemical product is of an electrocyclic reaction versus the thermal product? Well, we'll do that in the next lecture video, and it's going to involve molecular orbitals. So I'll just end by saying, can explain these reactions using molecular orbital theory. All right, and that'll be in the next lecture video. So until then, stay safe out there. Bye now.